Okay, so question 8 from the trial exam was actually question 9 from paper 1 2020. We've got the function and the sketch, and our first task is to differentiate the function, and we have a show that. So we have to show it can be written in this form. So let's have a look at the function. The first thing that's apparent is that I've got 3 factors. I've got 4x squared subtract 2 and e to the negative 2x. It would be beneficial if I just had 2 factors in my function so that I can perform a differentiation using the product rule. So I'm going to rewrite my f of x like this. So if I multiply the bracket by 4, I'm going to have 4x squared subtract 8, and then that's going to be multiplied by e to the negative 2x. Okay, I can now use the product rule. So if I call that 1, I'm going to call this one 2. Let's write our 2 by 2 matrix down. So we're going to have D1 and then D2. So we have to remember some relatively standard derivatives here. So we've got function 1, which is of course going to be 4x squared subtract 8, and then my function 2 is e to the negative 2x. If I differentiate those, I'm going to get 8x, and if I differentiate e to the negative 2x, that's going to be negative 2 e to the negative 2x. Okay. Standard derivatives, perhaps with a bit of chain rule thrown in there when we first were introduced to that. Right, okay, let's apply the product rule now. So f dash x is going to be cross multiplying diagonally. So I've got 8x e to the negative 2x, and I'm going to add, but I've got a negative 2 e to the negative 2x there. So it's going to be subtract 4x squared subtract 8 multiplied by 2 e to the negative 2x. I've already got the minus at the front. I brought that to the front earlier, so I don't have to multiply it again by a negative. Okay, now let's just expand this and see if we can recombine it, refactorize it. So the first term is fine. We've got 8x e to the negative 2x. And then if I multiply out all the second term, we're going to have negative 8x squared e to the negative 2x plus 16 e to the negative 2x. Okay, just explain what's gone on there. So I've multiplied the 4x squared here by 2 and e to the negative 2x. Okay, so that's given me the 8x squared e to the negative 2x plus the minus at the front. The next term is going to be positive because we have a double negative. So we have plus 16 e to the negative 2x. Okay, so we've got 3 terms now. I'm going to take out common factors across all of them. So let's see what we've got. Now I can take 8 out from each of those. I can't take an x out, but I can take an e to the negative 2x out. Okay, because that's common to every single term. That's going to leave me with x subtract x squared plus 2. Now, if you look at the answer, that looks like we've got pretty much it. It's just written in a different order, but essentially that is exactly the same thing. So we're in business there. So that looks good. Now for part B, it says hence. So using this information, find in its simplest form the exact coordinates of the stationary points of C. So that was part A. So for part B, let's have a look at the stationary points. Remember the key definition of stationary points. Stationary points occur when the gradient is equal to 0. So at stationary points, the gradient function f dash x is equal to 0. Now, it's actually nice this because the gradient function is factorized. So we know that 8 will never equal 0. We also know that e to the negative 2x can never equal 0. Okay, it has a range greater than 0. Okay, that can't ever equal 0. The only possible way is if 2 plus x subtract x squared equals 0. Now then, let's solve this quadratic. So I'm going to just rearrange this a little bit so it looks more familiar. We can factorize this as well. So we have x subtract 2, x plus 1. And that will give us stationary points at -1 and 2. Okay, so we have the x coordinates of our stationary points. Now, please read the question carefully. You're asked to find the coordinates in exact form as well. So we also need the y values. Now, if we plug x equals -1 and x equals 2 into our function, we should be able to write down the y values in terms of e. So when x equals 1, we have f of 1 is going to be, so going to our original function, it's going to be 4 lots of 1 squared subtract 2 multiplied by e to the -2 times 1. All right. Now, if we just simplify that, 1 squared subtract 2 is, of course, -1. Multiply that by 4. So that's going to be -4 e to the -2. Okay. So that's where our first stationary point is. And I've just realized I've put in the wrong value. Let me just restart that. I've put in 1 instead of -1. Let's try that again. So when x is equal to -1, we have f of -1, which is better. So that's going to be 4 multiplied by -1 squared subtract 2 multiplied by e to the -2 multiplied by -1. So that's going to give us, won't change too much, will it? So we're going to have -1 squared. So that's going to be -4 e to the power 2. So -4 e squared. All right. So our first set of coordinates are going to be at -1 and -4 e squared. Okay. And the second set of coordinates, if we sub in x is equal to 2, we're going to have f of 2, which is equal to 4 multiplied by 2 squared subtract 2, which is 2, isn't it? So that's going to be 8. And then e to the power -2 multiplied by 2. So we're going to have 8e to the power -4. Okay, so our second set of coordinates are going to be at 2 and 8e to the power -4, which is a positive number. Okay, so you can see those on the graph. All right, I'll just highlight them. So this set of coordinates here is at this point here, and this set of coordinates is right here. Now, for the last part of the question, we have to find the range of two functions which are transformations of our original function f. Now, looking at the first function g, it's equal to 2f of x. Now, you'll notice that the 2 is on the outside of the function, which means it's only affecting the y coordinates. Okay, so there's nothing happening in the x direction. All the action is in the y direction. So we could probably write down the stationary points here for g. Now, again, nothing's happening in the x direction. So the first stationary point is going to remain at -1. But because of the 2, I'm going to have to double my y coordinates. So it's going to be switched to or multiplied by 2. So that's going to be -8e squared. Okay, so that's a stretch scale factor 2 parallel to the y-axis. Notice as well that x is defined for all real numbers. So our domain doesn't change either. So I'm going to have to also state the other stationary point. So that's going to be at 2. And again, we double in the y direction. So that's going to be e to the -4. So if we're allowing any x value, we have to consider what doubling the y coordinates actually does. Well, for the range of g, what essentially is happening is this. If I just overlay on the sketch, this part is just going to go down, this is going to go up, and it's going to do something like that. Because it's shooting off up to infinity for x values less than -1, we have to state a lower bound for our range. So what I mean by that is g of x has to be greater than or equal to this lower limit, which is the first turning point where the minimum occurs. Okay, so for the range of g, we can see that g of x would have to be greater than or equal to that first minimum, which is -8e squared. Okay, so that would be the range. Now for the range of h, I'm just going to remove this curve so we can talk about this slightly different transformation. Now we've got something different going on here. We've got the same multiplicative scale factor, so we're still doubling all the y values. And again, nothing's happening to the x coordinates either. It's all happening in the y direction. So I'm still going to be at -1 and I'm still going to be at 2. But this time, once I've doubled the y values, I also have to subtract 3. So I'm going to have new y values at stationary points with -8e squared subtract 3, and also at 16e to the -4 subtract 3 as well. Okay. Now, how do I write down the range? Is it basically going to be the same thing? Well, no, because we have a domain restriction here. Okay, so imagine I double my y values. So I'm going to try and do that again. Something like this. Okay, but now because of the vertical translation, I have to drop these down by 3. So it's going to move down. But also I have to consider that I'm only taking x values that are greater than or equal to 0. Now that's really important. Now this means that the first stationary point plays no part whatsoever. I cannot use this. Okay, that's gone because it's not in my domain. Okay, I can only think about x values greater than or equal to 0. So it can't be anything to do with that. Looking at the transformation though, when x is equal to 0, it's going to cut somewhere low down on the y-axis. So if we figure out what that x value, or sorry, I beg your pardon, what that y value is, that will give us an indication of what the range is going to be. So let's look at this in a bit more detail. So when we're considering h, let's have a think about what h of 0 is. It's going to be 2 lots of f of 0 subtract 3. Okay. Now the function f, which we saw earlier, is as follows. So this is going to be 2 lots of 4 bracket 0 squared, subtract 2, and then we multiply that by e to the negative 0 because we sub 0 into the power as well. And then we have to subtract 3. So this is going to equal 8 multiplied by negative 2. And then e to the power 0 is obviously 1. So that doesn't do anything. Subtract 3. So we're going to have negative 16 subtract 3, which is negative 19. So that value is at negative 19. Okay. Now the horizontal asymptote, which is here, okay, that's going to be at negative 3. It's going to be as x approaches infinity, the y value is going to approach negative 3 because we dropped the y values down by 3, okay, using that vertical translation, because they were originally tailing off towards 0 or something like it perhaps, but in no way is it going to come close. I should have put negative 3 there. Is it going to come close to negative 19? We then have to consider an upper bound, okay? Now the upper bound is where our maximum is, okay? Now our maximum was at 2 and then it was at 8 e to the negative 4, but remember we had to double it and then subtract 3, okay? So this maximum here is valid. We're going to have to include this in our range, okay? So for the range of h, it's going to be as follows. H of x is now bound between a maximum upper limit of 16e to the negative 4 subtract 3, which is a positive value. But it's also bound because of the domain at negative 19. Okay, so that's a tough question. I know it's only 3 marks and I've kind of labored it, but I just wanted you to understand where these numbers have come from.